Okay folks, welcome to today's lesson. This is going to be the last lesson on acids and bases, and on Monday when I see you we will have a little bit of a revision lesson. So today's title, so reminder again, all the underlined words, they go into your good book. So our learning intention today is to be able to relate the colours of what's called universal indicator to the pH scale. So pause if you need to and write that into your good book. Now, usually, if we were in lesson at this point, we would be getting on our goggles and I would be setting you off on what it is that we're going to do. Obviously, that's not possible, so we have to do it a different way. So, in the assignment, you will see a link like this, and in a minute, I will show you what it would look like if you clicked on it. If for some reason this link does not work, then come back in here, please, and watch the remainder of the presentation, otherwise you can skip forward. Now in this little animation I want you to find out the pH of drain cleaner, of hand soap, of orange juice and of battery acid. So stick around for a minute while I just show you what happens if you click the link. When you click the link you get something that looks like this. So the first thing that we're going to do, we're going to ignore this over here because we're not interested in dilutions, is we're going to fill our little tub with some water. Now you know that water is a neutral solution. So in terms of our pH scale, you will see over here that the pH scale goes from 0 to 14. If I put this little probe in, it gives me a pH number. So anything that is neutral will always be 7. I would like for you now to find out the pH of drain cleaner, of hand soap, of orange juice and of battery acid. So you just fill it up with the component like so, you click it and fill it, and then drag this over to it and it will give you a particular pH number, and we'll see, can you get an indication of what sort of things are pHs 0 to 7 and what sort of things are 7 to 14. Now even if you've gone to the activity and it's worked and you've got your pH numbers, you may want to just even watch this just to see what it is, the things that I found out. Okay folks, this is just a video to show you the Phet activity if you can't get onto it because of the devices that you currently have. So over here on this left hand side you will see a scale. The scale goes from 0 to 14, and you will see that here 7 is highlighted. We've already talked about neutral. Something that has a pH of 7 is what's called neutral. Now pH, if you notice the way it's written, it is written with a small letter P and a big letter H. The small letter P stands for potential and its big H stands for hydrogen. And as hydrogen is an element in our periodic table, it's always written with a capital letter. So it's the potential of hydrogen. We're not going to go into what that means. Come to me in Leaving Cert Chemistry and we'll figure that out. So what you will notice is if the pH number is below 7, it is an acid, and if the pH is above 7, it is a base or alkaline. So we're going to start with neutral. I'm going to fill my little container with water, like so. The volume doesn't really matter. We would be using universal indicator, and I'm going to talk about that in our lesson. But universal indicator would change color depending on what we're putting it into. This is like what's called a pH probe. So you essentially put a probe into your solution and it gives you on a readout a value in which to do it. So here you can see that water, which is a neutral substance, has a pH of 7. So water is pretty much the only thing that is neutral, and that will have this pH of 7. And this is green for 7. Unfortunately, when we do acids and bases, they will also be green, but neutral. If you can think of neutral as being green with universal indicator, that will be really, really helpful to you. So we are going to start with things that we did the last day. So we'll go with hand soap, stuff that we would use at home to wash our hands, and you will see that here, we knew it was a base, but now this has a pH number of 10. So it's an okay base. It's not going to obviously damage your skin, which is great, and leave it scarred. And when we compare it to drain cleaner, which is a very, very strong base. Okay, I wonder while we do this, can you think what might be the pH number of a very, very strong base? Do you think it might be 14 or do you think it might be 8? Okay, so pH of a strong base is pH 13. So the further you are away from neutral, the stronger you are as a base. The further you are away from neutral, the stronger you are as an acid, down toward the zeros. So drain cleaner, if you were to put it on your hands, it will dissolve the fat in your skin and it will leave burn marks. It is a strong base. I don't advise doing it. So now we go to the other side, to things that are acidic. So we will look at orange juice. You may have had it for breakfast this morning. So do you think, what pH number do you think orange juice might come up with? Do you think it's down here, 0 and 1, or do you think it's up here, 3, 4, 5? Okay, so this is at the pH 3.5. It is, it's a weak acid. We drink it, it doesn't leave burn marks on our esophagus as it goes down or in our mouths. So that is a weak acid, so it has a pH number of 3.5. It's close to 7. If we have a look at battery acid, so when we did our acids the other day, it was sulfuric acid. Found it in car batteries, an acid that I have in the lab. You will see that if we look at the pH of this, it's down at 1. So this is a ridiculously strong acid. If you got battery acid on your skin, it doesn't dissolve the fat this time. It literally just burns the skin and will leave burn marks on it. So again, I wouldn't advise doing that. Now, if you've gotten a chance to play with the Phet activity, you might have tried the other weird and wonderful things in there, like milk, like chicken soup, like spit. Good times. For doing it with an animation rather than, we've spat in our class before, so maybe we do. So spit, ever so slightly alkaline. Okay, ever so slightly basic. So very weak acid, very weak base, which is why if you, God forbid, spit on someone, you don't burn their skin. Okay, that's all for now. Have fun. So now we're going to write our note on the pH scale. So, as we've said, it goes from 0 to 14. We don't have a 0 in this particular one, so there should be a little 0 here. There's not in this particular instance. But in terms of things that you need to know, so the pH scale goes from 0 to 14. If you are an acid, you will register 0 to 6.99999 recurring. If you are neutral, you will be 7 on the button, not less than 7 or greater than 7. And if you're a base or an alkali, you will register from 7.00000001 to 14. Okay, so pause now if you need to and write those notes into your good copy. So in the lab, which bottle do you think you should be extra careful with? Here I have 1 molar HCl, here I have 12 molar HCl. Moles to a chemist just means concentration. So which do you think you should be afraid of? So logic would say this bigger number. I should be afraid of 12 without a shadow of a doubt. But actually, in reality, both of these things would come with this symbol. They are both corrosive. They will both leave burns. 12 molar will be way, way better at giving you burns, but 1 molar will leave you with some burns as well. So that's why pH is really important. So in this instance, these guys have, as far as we're concerned for junior cert, pH of 0. Okay, the reality is they actually have a pH lower than that, but they're both ridiculously strong acids. Okay, so just be aware, you always either understand what the number is telling you or you know what the symbol means, one of those two things. So for your notes again, universal indicator is the thing that we would have used in the lab today. This is like red cabbage indicator. It is a very special kind of indicator which has a whole range of colors depending on the pH of your solution. Now we're going to just use these colors for our needs in junior cycle, and essentially what would happen is that if I change my pH of my solution down here and I add in my universal indicator, it would go these colors, but these animations unfortunately don't play on through max, so you can get a whole range of colors. So strong acid, strong base, weak bases, weak acids. 7 is going to be neutral. Okay, so pause now if you need to write that note into your copy. Okay, so now we're going to talk about strong acids and strong bases, and this is just the color of UI. So down here is going to be pH 0 and up here is going to be pH 14, and as you can see there's a range of colors that you have to kind of have an idea of in terms of strength. So the first rule is the stronger an acid is, the closer it is to 0. So these are the really strong acids down here, the kind of reds and the oranges. The yellows are weak acids. Okay. Again, I've color coded some things here. So strong acids is essentially in red, pH 0 to 3. Weak acids is in yellow. So this is yellow writing or yellow pen or yellow highlighter if you have it. And it goes from pH 3 to just less than 7. And we can also say that with universal indicator, they will be either red or orange. And again, weak acids will be yellow with universal indicator. So these two will get highlighted in yellow highlighter if you have them. I've also, just to kind of link them up, put them in boxes. So strong acids, pH 0 to 3 will be red and orange with UI, and weak acids, pH 3 to less than 7 will be yellow with universal indicator, okay, with UI. So pause now if you need to write these into your book. Okay, so this is obviously going to go into your book too, and it should be underlined. And again, the colors are important. So neutral, written in green, is pH 7 and will be green with universal indicator. So if you get a green color, that is going to be telling you that that particular substance is neutral. The last one that we're going to look at is, should have said pause if you need to write that, into your book. Okay, so here we're going to look at bases now. So the stronger a base or an alkali, so a base is a solid, an alkali is something that's dissolved in water. But the stronger a base or an alkali is, the closer it is to 14 on our pH scale. So 14 on our pH scale is now over here. 0 was over here the last time. And again, if you have a strong base, they will have numbers of pH 11 to 14. So this is written in blue, please note. And weak bases will be greater than 7, but up to about 11. And again, you get this deep purple or blue with universal indicator for strong bases. So that's kind of up here. And you get purple with universal indicators for weak bases, which is over here. And again, I've put these in boxes for you so you can link them up to yourself, for yourself. Okay, so pause this now. Make sure you get these written into your notes. Okay, so if we were in the lab, we'd be showing you these. So again, this is irritant, this is corrosive. They would be the symbols that are on the bottles. We would usually be using with irritants. So your job is to copy this into your good book. We are not filling in the name of the substance. If you want to have a guess, and I would suggest the Phet activity might help you, then you can fill this in, but in your completed one, I'm not really interested in it. Okay, so you're going to copy this into your book like so. So pause if you need to now and fill it in, and I'll show you the next bit. Okay, so once you have this in your book, you are going to put these colors into your table like so. So light blue, red, green, dark purple, and yellow. And you're going to use this, and you're going to decide on what pH number you would give for light blue, for red, for green, for dark purple, for yellow. You're also going to use these words and put them under here. So these refer to type of substance. The pH numbers are going to go in here. Okay. If you want to fill in this part here, you can have guesses as to what you think something light blue that might have a pH of whatever number you decide might be, then that would be great. Okay, you're going to take a photo of this, you're going to upload it to Edmodo for me, and you'll have one other thing that you're going to have to do. So this is the rag sheet. That's going to be present as a PDF for you. I will print it out for you when I get to see you again, but this is essentially everything that we would have done that we've done. This part back here at the bottom, we would have done this today. We would have, instead of me giving you colors and you trying to find out what things are, it would have been the pH scale and UI, and you would have investigated this. This is everything we've done. So you are going to go back now into your good copy, and you're going to annotate your notes with the correct hashtag, and along with your table you're going to upload this assignment onto Edmodo, and that will have to be done for midnight on Sunday. Okay, enjoy your Friday.